welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agriculture industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology. Hello, FarmBits followers and first-time listeners, and welcome to the FarmBits podcast. I'm Jackson Stansell.
And I'm José Cesario, and we are excited to have you join us for this episode as we continue our Spring 2022 series covering autonomy and robotics in crop and livestock production.
We welcome Chase Schapansky, Chief Technology Officer at GUSS Automation, to this episode of the FarmBits podcast to share with us about the autonomous spraying technology that they are bringing to orchards.
GUSS was born out of a need for automation due to labor challenges and safety issues, as you will hear Chase mention in this interview.
Along with this discussion, we take a deep dive into what makes the technology work, how it is designed to benefit its users, and how the technology can be leveraged for improved management.
With that background, let's jump into our interview and learn more about GUSS from Chase.
So I grew up on a farm. We farmed peaches, nectarines, cherries, grapes, things like that. Always raised animals for 4-H, FFA. So I've always had that ag background. I decided to go to college for mechanical engineering. So I went to Fresno State right out of high school. And while I was at Fresno State, kind of picked up welding, had a few different welding jobs, and then ended up working for CFS, which is Crinkle Farm Services, which is where GUSS was born. So I started working over there, just building, regular PTO pull behind sprayers, built a number of those, built some of our different vineyard machines that we run over there. And that's whenever Dave Crinklaw, the owner of CFS, had the idea of, hey, let's do an autonomous sprayer. He'd been wanting to do it for a while, but finally decided, I came on board, he kind of had the right people. So we set out and built the first one back in 2014. So me and one of the other guys at the shop there were the ones who built the first machine. And then once it was built, I kind of ran with it from there, figuring out the wiring, figuring out sensors, kind of bringing in some different software guys and putting all the pieces together to get it to drive itself. So that was in 2014. We ran it commercially in 2018 for the very first time. That was actually the first year we debuted it as well at the Ag Show in 2018. We ran it commercially for about a year and a half. And then in December of 19, we delivered the first unit to a customer.
So prior to that, were you just kind of running it on contract? Pretty much you would go out and do service spraying for folks?
Yeah, exactly. So that's what CFS does, is they have their own fleet of equipment and employees and everything. And then growers or whoever management will hire us to go out there, spray their fields. We also do some other things besides spraying. We do some pruning and machine harvesting in grapes, but spraying is really the main service that we do there. So that's why we wanted to automate a sprayer, because that's the business that we were in.
Gotcha.
And originally we didn't even want to sell GUSS. We just wanted to use it in our own fleet because we needed it. We developed it out of need. And then just with the reaction we had that first year and a half of operating it, we decided, we think we've got something here, let's run with it. So we split off and made GUSS Automation. And that's whenever we started manufacturing, selling, servicing, supporting the product and all that.
The products that GUSS offers, we've kind of already gotten at it, right? We're talking about an autonomous spraying machine, right? But there's kind of a mini GUSS, and I guess my impression is there's also a full-size GUSS. Would you mind kind of giving us a kind of an overview of the products and what's available from GUSS Automation?
Yep. So we started with our orchard GUSS sprayer. It's just a very, very competitive product with a typical pull-behind PTO sprayer. It is engine driven. It's got a 36-inch fan, so it's designed for almonds, pistachios, walnuts, and citrus is our main crops with that one. And we targeted there first just because almonds and pistachios are some of the biggest crops in California. They had wide row spacing. We knew we could get some big acreage growers with that machine, cover a lot of ground with it. And so as we've gone through, we decided to build mini GUSS, which we just released, about 4 or 5 months ago. And we're really excited about that. That's designed for a lot smaller orchards than almonds and pistachios. So that one's meant for like stone fruit, vines, maybe some kiwis, hops. smaller things like that. Really anything that's like a 16-foot row or narrower is what we'd recommend mini GUSS for. Than anything 18-foot and wider, we would probably recommend orchard GUSS. So it does have a little smaller tank. That was just part of what we had to do to get it to fit down those smaller rows. So those are our two ones right now, orchard and mini GUSS. We've definitely got some more projects in the pipeline that aren't really out yet, but we do plan to keep expanding our product line and, solve more and more people's problems.
What are the key problems that demanded an autonomous solution for this?
Yeah, so being in the custom spray business, commercial spray business, it was always hard to find employees every year. Orchard spraying is not a fun job at all. You sit in a tractor for, 10, 12 hours a day going 2 miles an hour with a big loud sprayer behind you. Sometimes there's a cab, sometimes there's not. It's just not a fun job. You've got all your PPE on, your coveralls, your mask, your gloves, everything. And obviously summer's a busy time of the year when everyone's spray, so it's hot and sweaty. And another thing that happens here in the valley is once it gets over about 95 degrees, the products become less effective. So most of our spraying happens at night. So like a 7 p.m. to 7 a.m. shift is real common around here. And so just finding guys who are willing to work those shifts, I mean, it's harder and harder to find them. It's not like we could really hire guys full time because it is a seasonal thing. So we're trying to hire guys for 6 months out of the year to work these not very fun jobs. And it just every year was harder and harder to find guys. We're having to turn down work because we couldn't get enough people to run all the sprayers that we had. So labor is really where it started. Just the nature of spraying, it wasn't a good job to have. And plus, for autonomy, spraying is a really good place to start because a sprayer goes through the field more times than any other piece of equipment that a grower typically owns. So it's not uncommon to spray your orchards, 6 to 10 times a year. Whereas, like a harvester goes through once or twice, maybe you mow a few times a year, things like that. Spraying is really what makes the most passes in a field. And you need a lot of sprayers in orchards because you're only spraying 20 feet at a time. It's not like you've got a big 100-foot boom on the back of your tractor. You're not covering much ground with each one of those passes.
For us out here in row crop country, I mean, that's a totally different, I think, that behind spraying, right, is small swath width, the overnight spraying, multiple passes throughout the year.
Yep.
It's totally different from a labor standpoint.
Yep. And it's not uncommon to do, 200 gallons an acre in orchard either.
So that, it slows you down even more. And so I guess when you're talking about a 20-foot pass, you're basically dealing with 2 rows of trees at a time, right? Is that pretty much what you're able to cover?
Yeah. So you're spraying 1 row at a time. You get half the right row and half the left row. So you're driving that sprayer every 20 feet, you're driving down the row.
We're talking about spraying. I mean, is this all types of crop protection products that might go out there? Are we talking fungicides, pesticides?
Yeah, any product that you would want to spray. We don't offer a herbicide right now, but anything that you would spray with an air blast sprayer, a lot of it is like fertilizers, foliar sprays, especially early on in the season when you've got bloom going on and you want to get some nutrients into that tree. That's real common in the beginning. Then once the fruit nuts start to set, then you get into your fungicides and insecticides trying to protect that crop that you have, make sure you don't get any bugs in there, disease.
And still talking about these products, what are some of the key product spray characteristics that have been achieved by this sprayer, for example?
Yes, so it first started as a labor problem, right? That's why we built it is we couldn't find tractor drivers. But as we've moved forward with the company and just learned more and more about the sprayers and what other benefits come with autonomy, is that you get a much more precise spray. There's a lot of human error that can happen when you're on hour 10 of spraying and it's dark and you can't see what gear you're in. All of a sudden you're going the wrong speed. And now you're not applying that material right. So with GUSS, you set the speed, you set the RPM, and that's just what it does. I mean, there's no other choice for it. That's all it can do. It can't grab the wrong gear. It can't go the wrong RPM. It lets you know whenever you're out of water. So there's no question of, did my pump lose prime? Did I run out of water too early? It all shows you very clearly on the screen that you have this much material left in the tank. You're running this gallons per acre. So if any of that goes out of tolerance, it alerts you right away. It's not like you spray half a tank and then realize that, oh man, I was going the wrong speed or whatever it is. It's all done very, very precisely. And then with that, we can record all that data. So now not only do we know we did a better job, now we can prove that we did the job correctly. So there's not a whole lot of documentation that goes into the spraying application right now. There's a little bit, it's mostly handwritten, but now that we have GPS, we have flow meters, we have valves, all that stuff, we can record all that data and show that to the grower, or the grower can use it for their own records, or if, regulations, Department of Pesticide Control ever comes in, then you've got that documentation showing that you did it all correctly at the right rate. It's obviously huge in food safety and things like that.
Yeah, I think the sustainability aspect and having that validation data is going to get to be a bigger and bigger value proposition for folks.
Yeah, it definitely is. We're starting to see a little bit of it. Nothing's really mandatory at this point, but the growers are definitely using it more and more often. Things that maybe they didn't think they were going to use with it, now all of a sudden they're seeing the benefits and keeping records just to have for themselves of it.
Yeah, and this is, I guess, kind of getting off on a tangent to some extent. I know like the regulatory aspect is one aspect of the reporting. Have you heard anything from growers as far as being able to get more value for their crops if they're able to validate certain spray practices or anything like that, or is that still maybe a ways off?
No, I haven't heard anything like that. I guess if you're talking like value of the crop, if you are doing a more precise spray, even if you increase your yields by 1 or 2%, that gets to be a pretty big number when you're talking 1,000, 2,000, 3,000 acres. And whether it's just you applied it correctly, you didn't have any dead spots, so that saved you, 1%, 2%, that those numbers really start to add up. So not necessarily that you get more for the crop, but there might be more of the crop because of GUSS.
We're thinking about like Midwest row crop sprayers. What we're really thinking about a lot there is nozzle design, right? And trying to get that right droplet characteristic to get down into the crop, penetrate the crop canopy. I assume that it's a similar concept here. We're trying to penetrate the tree canopy, right? And get that spray where it needs to be. But from the pictures I've seen of GUSS or videos I've seen of GUSS, it's a totally different sort of sprayer that we're looking at in terms of what the actual output spray looks like and how it's being distributed. Would you mind just explaining that a little bit to our listeners who may be unfamiliar?
Yeah, so unlike row crop, whenever you're spraying, you're just spraying downward, right? You don't have a fan. There's really no method other than water pressure. Maybe you have like a induction type nozzle or Venturi nozzle. But when you're spraying orchard trees, you need to get that spray 20, 25, 30 feet up in the air so that way you can cover the whole tree. So we have a big 36-inch fan on the back that's sucking air in. And then whenever that air, it kind of gets redirected out perpendicularly so we can spray outwards and upwards. Then we spray a atomized material mixture into that airstream, and that airstream is what carries the product up to the tree and gets full coverage on that tree. So really the air is really critical. There are air veins, so we can help direct air. Maybe you have a little taller tree, or maybe your trees aren't as tall, so you want to direct more of that spray towards the tree. So we do have a number of different ways to redirect that air and make sure that we're getting proper coverage on the tree. A lot of that's up to the user, the operator, to make sure all those are set right. That is very critical. Droplet size comes into play as well. Typically, the bigger the droplet, the farther you can carry it. The lighter ones tend to kind of get mixed up in the air and not go as far. So depending on tree size, that's going to change your nozzles as well. If you want a little bigger droplet, or maybe you want a little smaller droplet, you can obviously get a little better coverage with a smaller droplet, but it's not going to carry as far. So it's kind of a balance there. We have a pretty good setup for your typical almond pistachio tree. As we're getting into mini GUSS and dealing with different crops, we are starting to see some different nozzles come into play that are getting better coverage, because we're not trying to spray 35 feet in the air just to cover a vineyard. Now it's a little different market. So now you can get a little more fine-tuned with your nozzles to get a little better coverage, because you don't need all that air velocity. So us as a company, we're still kind of learning that side of it. All the growers kind of have their own approach to it. So we just try to be adaptable for whatever they want to do. They've spent a lot more time spraying in their own apples or in their own hops than we have. So we definitely take their ideas into play and see what they want to do, and just try to adapt to that.
And I believe that will depend on the grower, on the crop, and on the product that they are applying, right? And could you talk about the characteristics of operations that these early adopters of GUSS Tech are?
Yes, so some of the early adopters were commercial sprayers, kind of like we were actually. It just made the most sense, because they're not just going through a field 6 or 7 or 8 times. they're going through 6 different fields, 5, 6, 7, 8 times. So just the ROI was so much quicker for them, and they obviously had the same challenges as we had over at CFS. But then moving on to growers, it was kind of interesting. It wasn't the biggest growers who got on board first. They were kind of a little more timid. They wanted to see, how some other people were going to do with GUSS. So it was kind of the medium-sized guys where, management is still pretty tight. It's still, a relatively small company. The managers aren't necessarily the ones running it, but it's not up to the size of a corporate farm. So they had a little more flexibility in budgeting and, what they decide to do. There just wasn't like the bureaucracy that comes with any corporation that you're working with. So they seem to be the ones that really adopted it. They had, a decent amount of acreage, so they could definitely justify the cost, but they were also small enough to where, one guy could make the call. He could go out there, watch him perform, and kind of give his stamp of approval. Like, yeah, this is what we're going to do. So those were really our first kind of 2 main customers: commercial applicators and about medium-sized growers. And now that it's kind of been proven out in those markets, we're starting to see kind of on both ends, both the smaller growers coming on board and the bigger, large farms coming on board. Now that they've seen that it does work, it's been proven. And the smaller guys, we've, adapted to where it makes sense not to have a couple thousand acres. You can have a few hundred acres, and GUSS still makes sense to run it. So we're really starting to see kind of all sides of size of operators coming in now.
Sure. And I guess the labor challenges really hit everybody. You're not immune no matter what the size is, I imagine.
Yeah, pretty much. And even, these smaller guys, if they're spraying themselves, they'd much rather sit in the truck and watch the sprayer than have to sit on the tractor all night and do it. So yeah, they're happy that they don't have to sit there with all their PPE on. They can sit in the heated cab and the sprayer goes out and does the work. So they're happy too.
So let's take a deeper dive kind of into the GUSS platform itself and maybe talk about more of the technology, with you being the CTO. So what are the technologies that GUSS uses to kind of navigate these orders, make sure it's staying in the right spot to be able to spray the right way and not run over trees or anything?
Yeah, sure. So the base guidance feature is GPS. That's going to tell you where you're at in the world. You're going to make sure you're in the right block. You're going to make sure you're in the right row. All the things like that makes it that way you can have a nice, neat overview of your entire ranch, whether that's 500 acres or 5,000 acres. You can see where the sprayers are at, all that good stuff. The biggest problem with GPS for us is once you get into a orchard canopy, that GPS just gets terrible. I mean, all of a sudden you'll go from 1 meter of accuracy to 20 meters of accuracy, and it's really no good once you get under there. Especially late in the season, when you've got a lot of fruit and a lot of leaf on there, it just blocks all the GPS signal coming through the canopy. So at that point, we revert to using a LiDAR. We run a LiDAR on the front, so it's out looking for trees, taking measurements, showing us where the trees are, and trying to keep us in the middle. So along with that, then we have a whole slew of telemetry sensors, wheel encoders, steering sensors, gyroscopes, things like that. That's trying to do our localization, just kind of estimate our position as we're going through the trees, because we want to be able to show where we're at, make sure we're going the right speed, even more so than just staying in the center of the row. We got to know all those things as well. Sure. So we have a number of different sensors that's trying to do that estimation. Then once we pop out, whether that's a quarter mile, a half a mile down on the other side, we just do a double check with our GPS, make sure that our estimated local position, it matches up with the GPS position we just received in the turn, make our 180 degree turn, whatever that is, 20, 22 feet, and go back down the next row. So then all the spraying is controlled pretty much based on that localized estimated position. So based on the GPS map, we know where we're at by estimating, and then the spray and everything's triggered based on the GPS map. So we know that we're only spraying inside the field. We don't leave the spray on in the turns. We turn it on at the right time to where we're not overspraying or underspraying at the end of the row, all those kinds of things.
As far as I imagine there aren't many people, walking around the orchard at the same time that GUSS is in there just for safety concerns. But if there was an obstacle that was unexpected, what sort of safety mechanisms are kind of in place to allow a sprayer to operate autonomously within an orchard, vineyard, or something like that?
Yeah, so that's another beauty of spraying, is that you aren't supposed to have anyone nearby for about a quarter mile unless anyone who's authorized on the spray job. So that really cuts down on anybody who's out in the field. We do put up some signs letting everyone know that, hey, there's autonomous spraying in progress. We just try to kind of corner off that block that they're in at the time. But there's always going to be things that happen, whether it's a person or someone leaves a truck parked somewhere or a trailer. Maybe there's a tree falling. That's real common in almond fields. They've got shallow roots. So that LiDAR on the front, that's helping us do lane centering. It's also doing our obstacle detection and avoidance. So that works day or night. It doesn't need any backlight or anything like that. So that'll identify if there's something in front of the vehicle, whether that's a person standing there, a power pole, whatever it is. And because of how it works, we get this nice point cloud image. We can measure whether or not we have space to fit between the tree and whatever object it is. So the sprayer will take a measurement and decide that, yeah, I have enough clearance. I can drive around this. And if that's the case, it only has to scoot over a few feet. It'll just scoot over, maintain its speed and RPM and all that. And the operator will never even really know that it had to drive around an object. If it is an object that it can't fit around, then it'll send an alert back to the operator saying, hey, I'm blocked, there's something in my way. And then he can pull up the front view camera and decide what to do from there. Like maybe it's a tumbleweed that blew in because you're next to an open field. Then you could press like an override button and it'll drive over that tumbleweed. If it is a power pole or something, then he would have to go out there, take manual control of it, drive it around the obstacle, and then get it going again. He can drive it remotely from his operator station. We typically recommend against that. We like them to be able to see what they're doing. But if it's something that if it's your 10th time spraying the field and you're confident about it, then you could take over control from your operator station, drive around the object, and then keep going on your way. So maybe it only slowed you down 30 seconds or something like that.
And what are the challenges with powering the platform and replenishing chemical supplies on the platform?
Yeah, so with orchard spraying, you do a lot of refilling. We refill the tank about every 45 minutes to an hour. So pretty often. So in a shift, it's not uncommon to do 10 to 12 loads of material. So everyone that has a GUSS, we recommend them to run a nurse truck operation. So the sprayers are always staying in the field. We have a feature on there where you tell it how many rows it can spray. So if you tell it can spray 4 rows, it's going to spray those 4 rows and then pull into the 5th row and stop and wait to be refilled. So in the nurse truck, typically a nurse truck nurses 4 machines. So if you have 600 gallons on the machines, then your nurse truck needs to be about 2,400 gallons. So while the machines are out spraying out their material for that 45 minutes or an hour, the nurse truck can go back to the pump, fill up with 2,400 gallons of water and all the material to nurse those 4 machines. So that way he can do that. That usually takes about 30 to 45 minutes. So once the sprayers are stopped, he pulls up behind him. He has a hose on his truck with a big pump. Then he can connect up to those sprayers, fill them with their 600 gallons in just a few minutes. And then as soon as he's done, either he can have a laptop or he can radio to the operator and say, hey, machine number 1, it's full, it's good to go. And then they can send it and it's back on its way. That way those sprayers are only stopped for, maybe 5 minutes at a time. They're not spending all of their time running back and forth to the pump. So it really gets your efficiency up. It does add an extra guy, but it can make you spray twice as many acres as you would having to drive back to the pump. So that's how we recommend everyone who has GUSS to do it. We've seen quite a few creative things. Like the guy I was telling you, if one guy operates and he just sits in his truck, then he gets to go back to the pump, fill with water, and then go out and nurse his one machine. So his machine's always going. He has to, watch it and drive back to the pump. So you can nurse 1 machine, you can nurse 2 machines, you can nurse 4 machines. There's a lot of different setups that you can do. And we really like to help our customers with that because we want to make sure that they're being as efficient as possible with our sprayers. So we have a number of different companies that we work with on nurse setups, whether that's a trailer or a tank on a truck or whatever it is. We try to adapt and help out the customers, make sure they're running the efficient operation. And the user interface that we've built, it's very, very user friendly. And a lot of it is logistics, is just knowing where your sprayers are. How are you going to get them from point A to point B when they're not spraying? How do you keep the nurse truck moving? You always want to keep your sprayers moving. You don't want them to stop. So we've done quite a bit of work to make that as easy as possible for the operators.
Yeah. And since you mentioned that UI and kind of this whole idea of you can select, okay, you want your sprayer to run 4 rows and stop. Could you talk to us a little bit about how exactly you plan a mission for a GUSS automated sprayer?
Yeah, so it's pretty much a 3-step process. So step 1 is you need to map your field. if you go to a new field, you've never sprayed it before, so you're going to use the truck, and we have this box, we call it the truck box, that you put on top. It gives you like cell service, so you have internet, it gives you GPS location. So you're going to go out and you're going to map all the rows of your field and your avenues where the vehicle is going to turn. So you can do that just by driving the borders of the field. You don't have to drive every row. You just drive the borders of it and then enter in your row spacing, and it'll auto generate all the rows for you. So once you have that map, and you can add as many fields as you want, you can have one field, you can have 10 fields, typically it's 1,000 to 3,000 acres on one of these maps. You can add in like spray zones, maybe there's a section of the field that just doesn't have trees, so there's no need to spray there. You can add in caution points, so if you know that there's a spot where the sprayer is not going to make it, you can just drop a caution point, and then you have kind of a visual reference of that sprayer is approaching that caution point, that hey, I'm going to have to go help it get around because I know there's a power pole there or something like that. So once you have that map, you have that map for the life of the orchard. So typical orchard life is 20 years or so, 25 years. So that's kind of step one. You get your map. So then you go out to the field, you're ready to spray. You've got your 4 sprayers. There's a button that sends that map out to all the sprayers. And then you're going to decide how those sprayers are going to cover that field. We're always dealing with like varying obstacles or situations in the orchard. Like maybe the grower is irrigating, so we can only spray half the field. Or for whatever reason, they have a bunch of picking equipment on one side of the field and they're not going to move it for a couple hours, so we can't spray down there yet, or whatever it may be. So we assign routes on a daily basis. So that's where you would decide that, okay, sprayer 1 is going to do rows 1 through 20, sprayer 2 is going to do rows 21 through 40, whatever it is, assign them all out. And then at that point, you're ready to do step 3, which would be configure your sprayers. So now you're going to tell it how fast they're going to go, what the RPM is, what the spray pressure is, what their spray rate's going to be, all that kind of stuff. And it's going to maintain that as it drives through the field. So once you have those 3 steps done, you're going to choose your route, submit your configurations, and then you'll send your sprayer out. So from that point, the sprayer is going to take off driving autonomously. It'll go down to its first row. If it needs to be refilled, it'll stop right there and wait to be filled. Or if it's already got water, it'll just go into the field, kick the fan on, and start spraying at the rate it's supposed to. It'll spray until it hits its first refill point, and then it'll stop and wait for a nurse truck, and you just keep repeating that process over and over.
Yeah, it seems like a pretty straightforward process. I mean, obviously the mapping part, I think, seems like it's the most critical up front, right? To get that right. And once you have that, and then everything else kind of flows. Yeah,
the mapping is pretty critical. It's kind of the difference between having a rough spray and having a very efficient spray. Is you have a good map, you've got your caution points lined up, all that stuff's done and done correctly, then you're pretty much set. It's going to take care of itself from there. And so that goes back to the training. We definitely help train. We'll train the customer for a week or so, make sure they know how to map and how to operate, how to run the user interface, all that stuff. Make sure they're good to go.
You mentioned like about training these customers. What kind of software do you guys use for that, for example?
So all of the user interface runs on a Windows laptop. So we provide the laptop. It's like a Dell ruggedized computer. So it's got like rubber bumpers, dust proof, like a nice carrying handle and all that stuff that we provide with the sprayer. We like everyone to use the laptop that we provide, so that way we know it has the right specs, it's got enough RAM, the right processor, all that stuff to run our custom software that does the control and communication. So that goes out with roughly every 4 sprayers that we build. You get a laptop. We don't really manage it or anything. They buy the product, so it's theirs to keep and do what they would like with. But at least we know whenever it leaves here that it's a good laptop. It's going to function. It's not going to break anytime they get some dust on it or drop it out of the truck and things like that. Yeah, it just runs Windows. It's a very user-friendly program. We spent a lot of time perfecting it, making sure it did everything it needed to and not too much. We like to say that we have the most simple autonomous sprayer out there, as much as you can say that, but we try not to add too much, fluff or things that aren't really useful. I think we did a very good job, and people tend to pick it up. Usually they can train for a few hours and be operating GUSS on their own. It does take a couple days to kind of go through all the different scenarios that come up on an actual spray job, but usually within 2 to 3 hours, we can have, a brand new operator up and running and building maps and assigning routes and all that stuff.
So you mentioned kind of within the configuration process that the user ultimately decides, what kind of the sprayer operation parameters are, right? So your spray rates, your speed, and all that sort of stuff. Are those at all recommended by, say, for example, CFS, or are there agronomist recommendations that go into that, or do y'all basically just give the user full control?
Yeah, those usually come from the agronomist or PCA. That's who the recs are coming from. The sprayer doesn't decide how much to spray. The operator typically isn't the one who decides how much to spray. It's all coming from a agronomist deciding that, hey, this time of the year we need to put on 120 gallons an acre of these three materials. Then it's up to the operator to make sure the nozzles and the pressure are set right to hit that 120 gallons per acre. And if they're not on it, then Gus will tell you, hey, I'm off target by 5% or 10% or whatever it is. And then he can make some necessary adjustments, whether that's pressure, opening a valve, things like that.
Does these sprays affect like the soil compaction, or is the soil compaction a big issue for orchards, for example?
It's not too big of an issue. The biggest thing, as long as you're staying away from the root zone, which is, I guess, part of the reason to make the rows wide enough is so you've got somewhere to drive, also for the canopy to grow. But as long as you're not hugging one side by a lot, compaction's not really a big deal. We do have some growers kind of like Northern California or Pacific Northwest where they have a lot of rain. And that doesn't really become a compaction problem. It's more just, can you get through, making sure you have low compaction tires so you're not sinking in the mud and things like that. So we do offer a couple different tire options if that's the case, but it's not necessarily a compaction issue.
Well, how do you kind of envision GUSS, evolving over the next few years? I mean, do you see it being able to adapt to wind conditions and vary nozzle size or something like that to keep drift down? Or do you see some I don't know, nurse truck automation or something like that? I mean, where do you see this going?
Yeah. So whenever we started building GUSS, we wanted the mechanical spray side of it to be, simple, tried and true stuff. It's got a Cummins engine. It's got very typical nozzle setup, very typical fan housing setup. So now we're kind of solidified on the autonomy side. We've got that going. That was the hard part. So now it's kind of, okay, how can we make the sprayer better, more efficient? So we are working with a couple of outside companies who are a little more data driven. So one of our big things that we're working on right now is variable rate spraying. So it's probably very common in the Midwest that you spray variable rate. It is not done whatsoever in orchards. Like, that's not really a thing to do variable rate spraying. So there's going to be a few companies that are coming up that we're working with that will fly with a drone like a week before you want to go spray, run a few different camera imaging, and then they'll print out a shape file that says, okay, in this zone, zones 1, 2, and 3, and then you're going to assign, okay, I want 80 acres in this zone, 100 acres in this zone, and 120 acres in this zone. And then as the sprayer drives through, it's going to vary its pressure to match those rates that you've assigned. So we can get a much more precise, much more prescripted spray, not just spray the whole thing at 120 gallons per acre, because we want to get the worst of the worst stuff, but all the stuff that's healthier, it doesn't need all that. So that's one thing we want to work on, and really pioneer that in the orchard space. We've got everything on board to do it. It's just a matter of getting it tested, making sure those maps are consistent. A lot of growers are asking for it. So there's a few add-on things like that. We've talked to quite a few people that do yield estimation. So they would use like our onboard camera and run their algorithms to do yield estimation, since the sprayer is what goes through the field most often. That's where you're going to get most of your imaging from. It makes a lot more sense to do that than have a guy drive out there on a dedicated pass just to take pictures. It could just do it on board while it's already spraying. So there's a lot of like value add things like that we're trying to add onto the sprayer. So it's not just your typical orchard sprayer. It can, do some of these other things or have like a real advantage over some of the other pull behind sprayers, besides the autonomy, besides the, more precise spraying, besides the safety, all that. There's a few things we're working on like that, along with the added products that we're working on adding to our lineup.
What are some of the biggest weaknesses of the system, and how you guys are aiming to improve the system?
I guess the biggest weakness is dealing with small fields. So it was originally designed where you've got, big half mile by half mile blocks, so 160 acre blocks, and you could just sit out in that one block for 6 hours and never have to move. So as we've gotten to selling to customers, we're dealing with all kinds of different farms. Not everyone is out on the west side of California and has thousands of acres to farm. So we've had to come up with easier ways to transport the vehicle, figure out how to make it turn on tighter avenues, because now all of a sudden blocks are smaller, tighter together. So you have a little less room to turn. So there's some things like that are still a challenge to us that we're working through. We've come up with some new methods of how to get a sprayer from one block to another. You don't want to have 4 sprayers, but then it also takes 4 guys to move them. So how can one guy move 4 sprayers a mile down the road or whatever it is efficiently? So there's some challenges there. We have this mode called Follow Me. So you can line up all your sprayers behind your truck, and then they'll follow you from one ranch to another ranch, rather than having to pre-map all of it. And on avenues, a lot of times you don't have control of who's parked there, or who's traveling on them, things like that. So Follow Me allows you to kind of make your own path of wherever you want to go. Maybe there's gates closed that aren't usually closed, or whatever it is. That way you're not stuck to a predefined path. The sprayers will just follow wherever you drive your truck. It's not allowed on public roads, but anywhere that you have dirt roads to get there, you can use that method. So there's a few things like that that we're working on just to try and improve the product, make it a little more user-friendly, and kind of expand our market opportunity.
If somebody wanted to learn more about GUSS, how would they go to find out more about GUSS and what opportunities are available?
Yeah, so our website is gussag.com. It's got videos, talks over our models, has our address, all that good stuff. I'm on LinkedIn. If anybody wanted to reach out, whether it's a grower or a student or things like that, we're always open to having people here. We love to have people here. We have a pretty new facility, so we're pretty proud of it and like to give tours or whatever it is. We welcome people to come by, to just reach out, and we can set up meetings, or if it's just a Zoom call. I know not everyone's in California, so I'm always open to doing that. LinkedIn's probably the best way to reach me. I'm on there pretty much daily and get emails from it. So yeah, website and LinkedIn.
And Chase, to wrap up here our interview, what advice do you have for any of our listeners considering making significant spraying management decisions?
So there's a lot of benefits that come with a autonomous sprayer like GUSS, besides the gained efficiency and besides the labor challenge. Safety is a huge one. We didn't touch on it too much in this interview, but GUSS provides so many benefits on the safety side of it. You're no longer having to have a guy out on the tractor wearing a respirator. Not only the materials that he's spraying, but he's got to climb up and down that tractor. He's got a PTO shaft that's spinning. So there's a lot of safety benefits that come with GUSS, where you can get a guy off the tractor and it just clears up so many things that can go wrong out in the field, and gets a person off that tractor. That's really, really what we're trying to do. And GUSS is full of safety features, whether it's a LiDAR. We have a Defender vest. That's a new safety feature we just came out with. There's a lot of things on there, and it can really help with your guys' operation and ease up a lot of things.
Thank you to Chase for taking the time to join us on the FarmBits podcast. It was refreshing to learn about some new cropping systems and how GUSS is meeting the challenges of those systems head on.
My favorite part of this episode was hearing about how this technology is helping to advance variable rate applications in orchards and vineyards, which really hasn't been done much before.
Yeah, I agree. There was a lot of interesting content in this episode, but I think I had 2 favorites. Number one, it was really interesting to hear about how much of a demand there really is for safety, considering that these operators are exposed so much to the chemicals that they're applying, right? Because when we think about Midwest agriculture, you're thinking about being in a cab of a sprayer, right? And you're a pretty long ways away in the grand scheme of things and protected from the chemicals that you're spraying. It's not perfect, but we don't think about it a lot, I don't think. So that was an interesting aspect. And then I also thought it was interesting, we rely on GPS so much for our sprayers, right? Yeah. And we can basically rely on that technology to keep us well within a foot of our passes out there in the field. For them, going through an orchard, it's one of those things where they lose the GPS signal. And so they have to come up with augmented ways of keeping the path straight for these autonomous vehicles when you don't have an operator that's actually on the machine, which is a pretty interesting thing as well, and creates kind of a greater demand for those more advanced technologies. So with that, I'd like to thank you very much for taking the time to listen to another story of digital ag innovation here on the FarmBits podcast. And we hope that you'll join us again next week as we bring more to you within our autonomy and robotics and crop and livestock production series. Thank you.
Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback. So if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.